Okay, good evening. So today we're looking at worksheet 12A. The question says determine the value of each letter in the following figure with reasons. O is the center of the circle. Okay, so in other words, we must calculate A. Alright. So in pursuit of calculating A, we are told that AC is 8 centimeters. So now we can say that BC is 4. But very importantly, at this point, if it is not stated on the diagram, it's not given on the diagram, we must state it for a statement and give a reason for it, why we're saying it. Then we know that OB is 3, so that is 3. So we know that BC is going to simply be 4 centimeters. Why? Because it's given that AB is equal to BC. It was given to us. Okay? So that is 4. So we know we can apply Pythagoras to calculate A, but there's no 90. But we know, according to the first theorem in Euclidean geometry, is that if those lengths are equal, then this has to be 90. Okay, so that's a prerequisite for Pythagoras. We need a right angle triangle. So we firstly say that OBC is equal to 90 degrees Y, because bisector from center to chord. Okay, bisector from center to chord. Now we can apply Pythagoras. Now we say that A squared is equal to 3 squared plus 4 squared. It's your Pythagorean theorem. So it's Pythagoras with OBC equals 90 degrees. You can leave the word Pythagoras out, but you can't leave this out. Okay? If you leave that out, you will be penalized. So we got 9 plus 4, which is 25. The square root thereof is going to be 5 centimeters. Okay? Let's look at number 3. In number 3, as you can see here, there's C. So as you can see, this is your diameter. So C has to be 90 degrees. So C is 90 degrees Y, angle in semicircle. Okay. Okay, so now we're looking at number 5. As you can see, angle at center is twice angle at circumference. Okay, so angle at center is twice angle at circumference. So F is equal to half 78. Okay, which gives us an angle of 78 divided by 2, gives us 39 degrees. And the reason here is central angle theorem, or angle at center is twice angle at circumference. Okay. Now you see this angle is G here. Use a green pen. You can see that is G and this whole angle here is G. Why? Because the angles opposite equal sides radii. Okay, so you first say that OAB is equal to G. Why? Because angles opposite equal sides to radius. Okay, again, since it's not on the diagram, you have to state it. Okay. So now we got G here, plus G plus 78 equals 180. So 2G plus 78 is equal to 180Y. Sum of triangles, and it's triangle AOB. So twice G is equal to 102. Divided by that is going to give you 51 degrees. So 180 minus 78 divided by 2 is 51. Okay? That is your G there. Now we're looking at number 7. Number 7 is IJ, can be worked out. As you can see, the lines are parallel, so alternate angles are equal. So J is 65 degrees. So alternate angles with AB being parallel to DE. Okay. Okay. It's also 65 degrees. Why? Because of tan chord theorem. Tan chord theorem. Okay, now we look at number 9. Number 9, we are told that PR is a tangent. PK, sorry. So the tan chord theorem can apply if this point had to touch that. Since that point is not touching the circumference of the circle, tan chord theorem is not applicable. Okay. However, this is a radius. It's a tangent, so that's going to stand 90 degrees. So you're going to say n is equal to 90 degrees minus 60 degrees, which is 30 degrees. Why? Radius perpendicular to tangent. Okay. So that's 30 degrees. So what we note is that that is equal in length. Why? Because we're radii. So n is going to, what's it? P, sorry. P is going to be 30 degrees. Angles, opposite, equal sides, to radius. Okay.